Hello everyone, my name is Sachin Telalwar. I'm a senior software engineer passionate about building secure and scalable distributed system. It's truly an honor to be here at Conf42 and sharing my insight into how we can architect and secure healthcare system that go far beyond regulatory compliances. Today, I will walk you through guidelines and best practices that can help design a system which not only secure sensitive patient data, but also significantly improve operational resilience, efficiency, and patient trust. So the topic name is how to architect or architecting secure distributed healthcare system, which focuses on providing a blueprint for building systems that not only meet regulatory requirements like HIPAA, but also enhances real-time security, operational availability, and patient satisfaction while securing or preparing for the future stability. This is a slide which sets the foundation for what modern secure healthcare system should aim to achieve. It's about more than about just protecting patient data. It is about ensuring systems that should be responsive, proactive, and resilient in order to maintain the highest standard for the patient care. So in that, the first point I want to highlight is advanced security framework. So it is recommended to establish an advanced security framework that can reduce unauthorized access incidents up to around 99.89%. Multi-layered, and the system should have multi-layered authentication protocols should be employed to validate access requests thoroughly. So all these numbers I'm going to talk are retrieved from the papers which are already published, my studies, and the existing implementation. The second point I have here is that critical data accessibility. So in emergency healthcare scenarios, designing the system to enable sub-2 seconds data failure can be life-saving. Critical patient data must be made instantly available while preserving its integrity. The third point I want to highlight is proactive threat analysis, which is very important while designing a system. In the current age, we can incorporate AI-powered monitoring system that can significantly enhance anomaly detection by approximately 94.7%. And proactive analysis of such system helps identify potential threats before they escalate or into actual breaches, which are very important to take care of. And the fourth point on is accelerated incident resolution. The system should have a setup which should be able to handle the incident resolutions as quick as possible. It is important to architect security posture that should aim to reduce incident detection and response time from lengthy periods like 167 minutes, which is this number is taken from the existing research paper, and to down as soon as 12.3 minutes, ensuring threats are neutralized quickly. Going down to the next slide, system architecture, how we should aim to design these systems. So this slide discusses the critical architecture component needed for a secure, scalable healthcare system by layering distributed data management, microservices, advanced security, and efficient user interfaces. So first point there is on how we should design a data layer in the distributed world. We should architect the data layer to orchestrate the encrypted patient data, potentially managing volumes as large as in exabytes with validation rates of 99.997% to ensure the accuracy and protection for both system and patient. The second is how the microservice system or the core of it should be. It is advisable to build microservice-based core capable of handling millions of concurrent API requests and targeting numbers like in millions while ensuring zero downtime through the intelligent failure mechanism. The third is how the system should design its security middleware. The system should integrate real-time behavioral in the middleware to neutralize the 99% of potential threats and before they penetrate deeper into the healthcare systems. The third or of the fourth point on architecture is that user interface layer, which is very important to have a system resilient. So the system should design the user interface to HIPAA compliance while delivering the sub 2 seconds response time, especially for healthcare operations. Going on to the next slides. Sorry. So this slides explains about how the high availability and swift accessibility non-negotiable in healthcare system. As explained before, it's the patient life is on stake. So it is very important to have these systems in place. So this slide defines how ambiguous but achievable targets to ensure the system reliability under stress. So first point is about system uptimes. The system, we should design a system architecture to achieve 5 nines availability, ensuring uninterrupted access to healthcare service around the clock. And the second on this is that data accessibility. The system should ensure that accessibility target is again close to 5 nines, but enabling the clinicians and healthcare staff to retrieve information quickly, reliably, whenever needed, or 24/7. And more on the third point on API request, as explained in the system architecture, we should have infrastructure which is optimized to handle millions of API requests while maintaining sub 2 second response times, which is important to guarantee operational efficiency. Moving on to next slide. While designing this system, how we can have an audit mechanism. So this slide explains about auditing system. Such healthcare system should have some sort of audit trails to meet the compliance standard and ensure a traceability. So it outlines how there are multiple ways, but this slide explains how blockchain inspired methods can adapt to achieve the tamper-proof auditing. So the first point on auditing is that event recording. So a system should secure every interaction with the system and within the cryptographically sealed transaction blocks so that it's not leaked or it's not accessible to the people who doesn't have access. And this is to prevent any tampering or unauthorized alteration. A chain validation. So the system should employ distributed consensus mechanism capable of processing around millions of events to validate authenticity of every transaction, which is again very important to have this in place. And along with that, the third point we should consider that anomaly detection. The system should build a mechanism that identifies and isolates unauthorized modification within milliseconds. And this is to safeguard the system integrity proactively. And the fourth point is that about history of imputability. So we should preserve a tamper-proof chronological audit trail that not only supports the regulatory compliance, but also strengthens the trust in system, data handling and practices. So all these 4 points are very high level points and very important to have our audit system in place. Going on to our next slide. As threat evolves, so must healthcare system. And what does this mean is that the mechanism which were there in place 10 years ago or 20 years ago are not relevant now. So we should evolve with how the threats are evolving. So this slide highlights how predictive security models using AI and machine learning can detect, neutralize threats before they can damage in the healthcare system. So the first is that processing power, which is in current AI world, which is very important. So it is essential to architect a system capable of analyzing millions of security events per seconds. Utilizing custom design machine learning acceleration hardware enables rapid intelligent decision making systems, which are one of the key to have predictive security models. And the second on this is that, which is an extension of smart models, is that edge computing. So we should leverage a strategic edge computing nodes distributed across all healthcare facilities. And this should be real-time processing closer to source, and that will help it make sure that we are drastically shorten the detection times and response actions. And while doing those, so it is very important to have accuracy metric, which makes sure that the detections are moderated rightly. The system should have models, if we are designing that way, which should target close to 99% of threat detection accuracy, which in this high-stake healthcare environment. And while doing that, we should reduce the false positive rate to a remarkable close to none, or maybe 0.03%, which outperform the other industry average of 2.3%. And the fourth point is very important on this slide is early detection. So build a system that can identify potential breaches, which is based on the history. We should, and also this goes hand in hand with audit trail within a minute. And we should deploy such sophisticated countermeasures within 200 milliseconds to neutralize the threat. Going on to the next slide. So when we do or analyze or implement a such system, it is very important to analyze how this will impact the patient confidence. So security investment aren't just technical or just to satisfy the compliance that directly impact the patient trust and confidence. So this slide basically highlights how the secure architecture influence the patient satisfaction and their privacy perception. First, on data trust. So healthcare providers should aim to have patient trust and privacy satisfaction. A significant uplift demonstrate a tangible proof of impact. So the first point is here. We can see that the before implementation and the after implementation, the data trust. And the second bar here, it also explains how with this system implementation, privacy satisfaction has been increased, which is again very important while architecting such system. And on the same line, security confidence comes into picture, and it based on the studies, it has been found out that if we have all the systems in place, as explained briefly above, the security confidence also increases. Going on to the next slide, we discussed a lot of points and how to architect, design, what things to consider, how we should incorporate AI models. But ultimately, it is also very important to consider the financial impact of such technical implementation. Implementing strong security not only protects the patient, but also delivers clear financial returns. So this slide explains how security investment translates into saving, efficiency, and risk mitigation. So the first point on that is that annual cost avoidance. By preventing breaches and regulatory penalties, healthcare organization can save approximately 3.2 million annually through proactive security frameworks. So this number is, again, it could be north of 100 million or 1 million, but ultimately it boosts up or avoids the annual cost and boosts up the revenue. And compliance efficiency. So automating regulatory reporting and enhancing security controls can lead to 97.8% reduction in reportable compliance incidents. And it reduces the audit preparation workloads by 86%. And the third is operational saving. Through AI-powered workflow automation, organizations can boost the efficiency of their security operations team by more than 50%, but research shows if we have the systems in place discussed above, the 70% or 74% security operations can be lifted up. Yeah, to summarize on operational saving, from a couple of hours to minutes, that is the goal of the system should be. Going on to the next slide, implementation strategy. Successfully deployment of secure system requires a strategic, phased approach. It has to be very well thought out. So this slide provides a blueprint to follow when implementing secure healthcare system and how we can architect it. First, infrastructure assessment. So we should start with a comprehensive evaluation of existing systems to uncover vulnerabilities and operational gaps. We should look at what is the current rate of API request we get, and how if the load varies based on the season or any particular part of the or month of the year. So that all will help in infrastructure assessment and designing or choosing an infrastructure. And architectural blueprint. So the system should develop a customized security implementation plan tailored to each healthcare facilities or system's unique environment, ensuring scalability if in case there is a need of. And the third is phase deployment. So implementing security components strategically in phases, it ensures zero disruption and to essentially the patient care services. And also the phase deployment makes sure that along with the audit trail, we find out the weakness and strongness of our system. So the phasing out deployment in different layers, we can analyze system pretty early and fix it. And continuous optimization. Designing system that dynamically evolve by integrating real-time threat intelligence and adaptive learnings. It basically ensures that defenses stay ahead of emerging threats, which is very important. Going on to next slide, future selling capabilities. As I mentioned, healthcare system must be prepared for future, must be prepared for future scalability. So this slide describes how to architect or design a system that can withstand tomorrow's challenges, scalability issues, including AI evolution, quantum computing threats, and massive data growth, which is very much possible. So first point on that is advanced AI integration. So architect security system that self-evolve without human intervention by integrating AI models is a gold standard. And that way we can make sure that we are going hand in hand or one step ahead even before the threats are generated. The second is that quantum resistant encryption. So future-proof security by adopting cryptographic protocols designed to withstand attacks from quantum computing and ensuring long-term resiliency. And the third is that expanded data capacity. So as explained above during our infrastructure slide, we should plan to have infrastructure capable of managing petabyte of data. So this number 45.7 petabytes is the number got from the recent one of the biggest healthcare system that receives that much data. And yeah, so going on to the next slide, which is a key takeaways. To conclude, this slide reinforces the holistic approach that is needed to architect secure, scalable healthcare system that are not only compliant but truly resilient, intelligent, and future ready. The first point is that security beyond compliance. So build security architecture that exceeds minimum regulatory requirements while driving operational efficiencies. The second is predictive protection. There are multiple ways, but with today's AI-driven world, we can include or adopt AI-driven security models that proactively detects the threats and ensuring protection well before system would react. And third point is that proven results. So we should focus on achieving measurable outcomes such as into 5 nines or close to 5 nines and future-ready architecture. So design system that considers growing data demands, evolving threats, and new technology all the way through 2027 and beyond. Thank you.